So today, Dr. Honig will not be able to join us, so I will do this lecture for him. So today, our lecture topic will be about interface in object-oriented programming. I think this is probably the last topic that we want to introduce in this course about object-oriented programming. So let's take a look at this problem. So let's say we have a class ego that we derived it from the base class animal. And then we have another class, Lion. It's also derived from the base class animal. And now we want to implement a third class called Griffin. So what we want to do is, let's see if multiple inheritance is available to us in C#, do we want to make Griffin inherit from both ego and Lion class? So especially consider the fact that both ego and Lion are derived from the base class animal. So they have a common superclass, and then you want to create a Griffin which comes from ego and Lion. It turns out that multiple inheritance is a bad approach. Why is that? So take a look. So let's say for animal class, we have three methods here: greet, eat, and excrete. They are all declared as virtual, means that their subclass or derived class can override them. And then we have our Lion and ego class. Lion overrides the greet, eat, and excrete method, and so does ego. And then if we want to inherit from both Lion and ego to create our Griffin, the problem comes. So first thing, the biggest problem is the ambiguity. So whose greet method should we inherit? Whose eat method should we inherit? And whose excrete method? So this is called the deadly diamond of death. It's because it looks like a diamond shape. It's so two classes originate from the same base class, and then a new class inherits from two classes. So this causes huge problem in the inheritance because we don't know which method we should inherit. And another problem of multiple inheritance is that its complexity. It's complicated because if you have one class inherit from multiple classes, you have a lot of complicated relationship. How complicated is that? Well, I will have an awesome instructor from Berkeley to explain that to you guys.
Okay, let's talk about designing with multiple inheritance. Usually you don't, because it's complicated. It's hard for me to construct an example in code of just how complicated multiple inheritance is. So I'm going to show you an analogy instead. The complications of biological or human inheritance. So how do you think about how you came to be? Well, you think you had a grandma and a grandpa and a granddaddy and a grandmammy, and they had your mom and dad, and then there's you. That's how the world works, right? And if your grandma and your grandpa have another kid, well, that will be your aunt. And other strange things can happen. Like, let's say, history went as it went, and so your grandma actually had a kid with some other guy. That'll be your half aunt. So half aunt is a technical term. It describes someone who you share one grandparent with. And if your half aunt gets together with some other guy and has a kid, that's your half cousin. Natural thing to have. But this picture of the tree just growing and growing, the farther back in time you go, must be inaccurate. Because it's growing exponentially. And yet there were fewer people on Earth 200 years ago than there are now. So there must be some sharing in the tree. I mean, how would that work? Well, let's say that this some guy was not just some guy, but in fact was Granddaddy. That's your double half aunt. there are real terms for this stuff. I mean, you got to know what your relationship is with this person. You're a double half aunt. So you have a half an aunt with grandma, you got a half an aunt with granddaddy. If you can have a double half aunt, of course you can have a double half cousin. So a double half cousin is someone who you share two grandparents with. If you could have a double half aunt, you could have double half uncle. So a double half uncle is a child of grandmammy and grandpa. And you can probably see where this is going. What happens if this some other guy is in fact your double half uncle? Well, nothing that weird has happened. But that is your quadruple half cousin. Someone who you share all four grandparents with. So what's the moral of the story here is that multiple inheritance gets complicated very quickly, so you might be careful when you use it. Don't use it too much. And that's all for today. See ya.
Okay, so in that video clip, it basically explained us why multiple inheritance is complex, because it just grows and grows exponentially, and it's getting harder and harder to figure out the relationship between classes. So we don't want to do that. So what should we do? And turn it out, the solution is interface. So an interface, let's say the real world interface, for example, like USB port, power outlet, a car driving system, and the computer. So what an interface does is that it gives you an abstraction, or gives you a certain behavior. It describes the behavior, but does not implement that. What does it mean? So for instance, let's say take a look at this USB port. It only gives the shape of it, which is like all the wires, but it does not define what device you can plug in. You can plug in your mouse, your keyboard, your Bluetooth headphone. You can plug in your phone to charge it. You can basically anything that has a USB interface can be plugged into it without worrying about what the device actually is. So interface describes the behavior of the type, but does not define it, or does not implement that. In the programming part, interface only contains the signature of function, but does not implement it. So for example, let's say our function, we have something like print array. So instead of implementing the print array method, it just say public void print array, parentheses, and semicolon, and that's it. Does not give you any implementation of the print array. So what do we do with the interface? Well, if we want to use the interface, a class must implement that. And when the class decides to implement an interface, it must implement all the methods that's specified in the interface. And the advantage of using interface is that a class can implement multiple interfaces at one time, even if a class can only inherit from a superclass at one time. So because a class can implement multiple interfaces at one time, therefore we can use the interface to mark multiple inheritance. Okay, so let's go back to our Griffin example. So how do we want to implement Griffin while not inherit directly from Lion and Eagle? It turns out that we just need two interfaces to make Griffin behave similarly to Lion and Eagle. So what are the features of Lion and Eagle? So for Lion, it can run. So therefore, we can define an interface called iRunable, and which only contains one method called run, void run. And what is the feature of Eagle? One of the features is it can fly. So therefore, we define an interface iFlyable and only contain one method called fly. And note that for C#, when you define an interface, you must have a capital letter I in the front. So therefore, there will be two capitalized letters in the interface name. So both I and R are capitalized, and both I and F are capitalized. Okay, so once we have these two interfaces, we can make our Griffin to behave similarly to Lion and Eagle. So we start with our base class, which is animal. And in this base class, like we had before, we have a name, we have the gut, we have the constructor for the animal. We have a method called getName, which gives us the name of the animal. We have this greet method that allows animal to greet to us. We have eat method, which basically takes a string and adds to the gut, and the xGreet method. Everything we have seen so far. And of course, we have this interface iFlyable, which basically is any class that implements this interface need to implement this void fly method. And similarly, we have iRunnable interface contains a void run method signature. Okay, now let's go to our Eagle class. So before, our Eagle class only inherit from animal. And now I'm going to make a little bit different. I'm going to make it not only inherit from animal class, but also implement this iFlyable method. So therefore, an eagle does not only have all the traits of animal, but also can fly. So what does it do? Again, I define the constructor using the base constructor from the animal class. And I override the greet method so that the eagle can greet a little bit differently. And then, like I said before, I need to implement this fly method because in the class declaration here, I said I want to implement iFlyable interface. So therefore, I must implement this fly method. And again, what the fly method do? I just say I am blah blah the eagle and I can fly, and that's it. And of course, because it's a derived class, I can add some feature to it. So I add this method called hunt so that the eagle can hunt as well. And now let's take a look at a lion class. So again, it's a little bit different from the lion class that we discussed before. It not only inherit from animal class, but also implement the iRunnable interface. So again, constructor, greet method, and then because I said I want to implement the iRunnable interface in the class declaration part, I must implement this method called void run. And what does it do? It simply basically print out I am the name of the lion and I can run. And again, because lion is a derived class of animal, so I want to add some features to it. So the one of the feature I add to the lion is it can roar. And what does it do? I just print out this. Okay, so with these two just show you how eagle and lion can be a little bit different from before. And now let's take a look at Griffin. What my Griffin class does is I make the Griffin inherit from its animal class, and meanwhile implement two interfaces instead of just one. Implement this iFlyable interface and iRunnable. And again, because it inherits from the animal class, I can use the base constructor from the animal class to implement this constructor for Griffin. And again, I override the greet method. And because I implement both iFlyable and iRunnable interfaces, therefore, I must implement this fly and run method for Griffin. And now, as you can see, Griffin has the trait of animal, iFlyable, and runnable. Therefore, Griffin is a little close or similar to a lion and eagle, even though it cannot hunt, it cannot run, or it cannot roar. So let's take a look at our executable program, our main program. So what the main program does is we first declare an ego. We want to check out the ego's behavior. So we instantiate the ego class and get an object called cloud. We can make a cloud greet. We can make a cloud fly because they are because cloud can greet because it inherits from animal. Cloud can fly because it implements the iFlyable interface. Cloud can hunt because it's the method that is declared in the ego class instead of the animal class. And cloud can eat because it inherits from the animal class. And then we can make cloud extract and check out its faces. Similarly, I instantiate an object for learn called Simba. Again, we can make Simba greet and run because Simba inherits from animal class. That's why it has a greet method. Simba can run because it implements the iRunnable interface. Simba can roar because this roar method is defined in lion class, and Simba is a lion. And Simba can eat and excrete because Simba is an animal. Now we take a look at our griffin. So I instantiate an object of griffin called Falstad. And what I can do is I can make a Falstad greet, eat, and excrete because these methods are inherited from the animal class. And meanwhile, Falstad can fly. It's because it implements the iFlyable interface. And similarly, Falstad can run because it implements the iRunnable interface. So as you can see, ego here can only fly and hunt on top of those methods inherited from animal class. And the lion can roar and run. But our griffin can run and fly at the same time. Therefore, we can say, okay, now we make something happen. So we make our griffin behave similarly to a lion and an eagle. So that sounds more like a griffin, even though it cannot hunt, it cannot roar. So what does the program look like when it executes? So first thing, it prints out the eagle's behavior. It prints out, "Hello human, I am Cloud the Flying Eagle. And I am the eagle, I can fly." And if you go to our main code, the cloud first eat a mouse. Okay, I should say the first thing is the cloud hunts cloud itself, and cloud eat a mouse. And then when it excrete, you can see cloud faces its cloud because it hunts cloud and eat itself. It's a little bit weird, but we won't cover that much right now. Now we take a look at the behavior of a lion. As you can see, when lion greets, they say, "I'm Simba the lion, ow." And when the lion run, they say, "I am Simba the lion and I can run." And then when we make Simba roar, it print out the roar of the lion. And now let's take a look at griffin. So what griffin does is that it has its own greeting method, it has its own fly method, and its own run method. So griffin can run and fly differently from a lion and an eagle. So in terms of this, we successfully make the griffin inherit from both, quote, inherit from both lion and eagle, even though what actually happened is not that case. So what does the class structure look like? What's the relationship look like between those classes? If we did the multiple inheritance way, what will happen is we make lion inherit from animal, eagle inherit from animal, and griffin inherit from lion and eagle at the same time, which is complicated and won't work. Instead, we use the interface. So what happens is that lion inherit from animal, implement I-random interface. Eagle inherit from animal and implement I-findable interface. And then we have griffin. Inherit from animal and implement two interface. So therefore, it looks like, because griffin inherit from animal and implement I-random, therefore it looks like griffin and lion have something similar. Or we can say griffin is similar to a lion. And similarly, we have griffin inherit from animal and implement I-findable. Meanwhile, eagle is doing the same thing. So therefore, it looks like griffin is similar to an eagle. And by doing that, we successfully made griffin behave similarly like a lion and eagle. And meanwhile, we also avoid the problem caused by multiple inheritance. So in this picture, we actually only every classes only inherit from one animal class, and they just implement different interface. Therefore, they behave a little bit differently, and which makes them look like inherit from different classes. Okay, so what's next? So as you can see, the benefit of using interface is that we can fake multiple inheritance. We can reduce the code complexity. So basically what happens is that we instead of inherit from different classes, we just define some interfaces and make different classes implement different interfaces. And another benefit of this is it decouples classes. So if we make class directly inherit from another class, it makes the two classes tightly bonded. But if we make an interface between them, it will make them only dependent on the interface instead of directly dependent on each other. This may be a little hard for you guys to understand, but you guys will learn more about this in Comp 313 and 413, which is an intermediate object-oriented programming course. And of course, interface gives us more abstraction. So instead of knowing what the method for each class, we just need to know the interface and use the interface to interact with objects. All right, I think this is a lecture for today, very short. Now we're going to do lab a little bit. So I believe we're supposed to do the iBook lab, or I should say book list lab. It's due tomorrow, I think. Tomorrow, looks like it's tomorrow midnight. For the rest of the lecture, we can just do, rest of this class, we can just do the lab. And I want you guys to know that I also have office hour every Friday morning at Loyola Hall from 10 to 12. So if you want to see me and get some help, you're welcome to visit me. That's it for today. All right.